How do you store data effectively for your application? Imagine you have two distinct choices for managing information. Think of SQL databases like a formal filing cabinet where you organize everything in precise slots. This is structured data, perfect for when accuracy matters most. On the other hand, you have NoSQL, which acts like a flexible storage bin for all kinds of varied shapes and sizes, giving you more creative freedom. For that filing cabinet, you rely on ACID, a set of rules ensuring strict reliability, so your data is always consistent and secure. Conversely, the flexible bin follows base principles, prioritizing speed and massive scale over immediate perfection. As your needs shift, you might move along this spectrum, from highly structured and predictable relationships to more complex and unpredictable ones. Ultimately, you are choosing between the rigid, organized nature of a cabinet or the versatile and expandable capacity of a bin. Is your database too slow? When you send a write request from your application to a database, you are essentially asking it to commit new information to disk. If your performance lags during this process, it often comes down to your read and write ratio. This is simply the frequency of data retrievals versus the frequency of data updates. Think of a write-heavy workload like a narrow turnstile where only one person can pass at a time. It requires a specific, streamlined structure. In contrast, a read-heavy workload is like a complex intersection where many users need to navigate different paths at the same time to grab information. Because these patterns differ, you choose different tools. A document store is often optimized for quick writes, while a relational database excels at managing complex reads. The secret is to match your database structure to your actual traffic. Why can you never have a perfectly reliable database? You start with two servers, A and B, connected by a network that allows them to share information constantly. Watch what happens when you send a data packet from server A toward server B. Suddenly, the connection snaps. When two servers lose their link and cannot communicate, you call this a network partition. It is a fundamental roadblock in computing. Think of it like a three-legged stool, representing consistency, availability, and partition tolerance. If you remove the consistency leg, where everyone must see the exact same data at the same time, the stool wobbles. If you pull out availability, the guarantee that your app never fails to respond, it collapses again. Remove partition tolerance, which is the system's ability to survive that broken network link, and the stool falls once more. In the world of distributed systems, you cannot have all three at once. That is the CAP theorem in a nutshell. You usually pick two. You might choose CP for strict data accuracy or AP for constant uptime, but you cannot have CA without risking total failure during a network break. When that partition happens, you as the architect are forced to choose. Do you prioritize showing your user the most current, fresh data, even if the service might pause? Or do you keep the system running and available, even if the information might be slightly outdated? That is the trade-off you face.